Zhuang Haokun is a scientist working at Taiwan's top research academy, and he has a dream.
Since I was a very young kid, I always want to, predict an earthquake in the future.
Zhuang and a team of fellow researchers say they found a way to do just that.
Their method for predicting earthquakes rests on a deep connection between the skies above Taiwan and the ground below it.
Taiwan sits on a fault between the Eurasian plate and the Philippine plate, which is pushing northwest at a speed of about 80 millimeters a year. When it moves, it squeezes the rock and creates an electrical field. Zhuang and his team say that before earthquakes, that electrical field is big enough to disturb the ionosphere. That's a region of the atmosphere which begins at about 60 kilometers high and extends into outer space.
First, they predict how many electrons will be in the ionosphere above Taiwan in the next hour.
Then they compare that to the real value and write down the difference to see how wrong they were. They repeat that every hour for one stage of 15 days, and then another stage, also of 15 days.
Finally, they look back at those two stages to see how right or wrong their predictions were.
Here you can see their predictions were close to reality, so they say there's no earthquake coming. But here, their predictions were off in the second stage, so Zhuang and his team would say a magnitude 6 earthquake is on the way.
So, is that it? Have Zhuang and his team cracked the case? Well, earthquake prediction is the holy grail of seismology, and the field has seemed to be on the verge of a breakthrough for decades.
In the 1970s, scientists were optimistic that they were close to their goal. An official US government research panel wrote in 1976 that a scientific prediction will probably be made within the next 5 years for an earthquake of magnitude 5 or greater in California. It said predictions could be routine within 10 years. But that optimism soon soured. In 1997, some researchers even said predicting earthquakes is effectively impossible.
Now, though, advances in technology may have brought it within touching distance.
它的方法其实是不错，也很值得我们也许未来可以尝试应用于实物上面。
Paul Xinjie works at Taiwan's Seismological Center, sending out alerts when big quakes hit. He says Zhuang's research is sound, but they're not quite there yet.
如果要发布这个地震预测的资讯的话，通常还需要它的位置跟它的规模这些资讯。
For our study now, is only can predict the occurrence time. Right now, we cannot predict the location like the epicenter of an earthquake.
Without a specific location or magnitude, Zhuang's method does not amount to a full earthquake prediction yet.
如果说现在预测地震的话，我认为现在这个当下这个时间点，可能要问上帝。我认为这个可能在未来的某一个时间点，可能发生的。那只是说现在这个时间点，我们还没有办法。
On average, Taiwan gets hit by 3 earthquakes with a magnitude bigger than 6 every year. Most are harmless, but some, like the 1999 Gigi earthquake, kill thousands.
Zhuang and his team's research may have brought science closer to saving those lives, but for now at least, seismology's holy grail is still just out of reach. Lien and Staś Butler for TaiwanPlus.